Hello and welcome to Apropos, a conversation between Clojure programmers. We're going to discuss a few Clojure news items and share our opinions on them. We'll be posting this to YouTube, so please feel free to comment there. We don't do it live anymore, just a little clarification because it's really technically too challenging for us. We're only four moderately intelligent programmers. Can't figure it out. So let me introduce the panel. We got Mike,
Hello.
Mia, and I am Eric. We have a couple of topics today. Where did I put them? Here we go. First topic is Ray's topic, and Ray is not here. So we're talking about transducers, and particularly transducers as a way to write more modular code, as opposed to just for their performance characteristics. So, Mike, could you intro this topic?
Ray was chatting with me. He's kind of like getting back into the cleanliness of functional programming in general. You know, like the reason we're all doing this stuff in the first place, right? It's like revisiting and redoubling down on like, hey, let's talk about this stuff. So Ray was kind of messing with transducers, and he started down this path of like, hey, they could be thought of as a cleanliness thing, or closer to not maybe I shouldn't say closer to functional, but they afford you some things that you didn't have before, where you can succinctly define things. If you think about like the way you have function values, and you can pass like a function into the map function, right? That's a new fundamental thing with functional programming, and perhaps along the same vein, transducers lets you define a transducer. It's this new concept that lets you clean up things and pass those around instead, and work with those. That was what he was getting at. And it's not so much like, I'm guilty of this, is that you kind of latch onto the performance characteristics of transducers. And,
Right.
and it is true that that's a consequence, but I don't think that's why they were created. Maybe that just is a natural, nice side effect of what happened with them.
Yeah.
The motivation for transducers was core async, right? I mean,
yeah, as I understand it, Rich Hickey had been going deep into this idea with reducers, the same kind of idea that you could somehow separate out the data structure from the operation in the kind of, like, I want to say, visitor pattern kind of way.
Okay.
And when he did reducers, he came up with this idea of the difference between I reducer and I something reducer. Like, one requires, I don't remember what it's exactly called, but it requires the initial value,
Okay.
and it has some different guarantees and properties.
Mm-hmm.
And if you have one of those, and I think vector, all the trees have it, the vector and stuff, they have a different property that lets it run in parallel when you use the reducers library. But all of that
associative property, maybe, or
yeah,
like
if the operation is associative, it can be broken up and run in fork
parts.
join.
Yeah. Yes. Yeah. Fork join. Yeah.
And you can't do that with a linked list, because it's just by definition linear. But if you had a list that was like a chunked list, right, which it does exist, then it can be done in parallel. But of course, your operation needs to be associative, etc. But you need that, like, initial value, like what is the value at the bottom, right? Anyway, when he was working on, then he started doing core async, and he realized, well, there's this other thing that we could decomplect, right? We could separate out that it shouldn't matter what the vehicle for the value is, right? Map is typically defined in terms of a linked list because it's easy, right? It's kind of, it's an easy function to write. and it separates out the operation on the value from the actual list you're running it on. And so in a way, it represents this recursion over list
Mm-hmm. Yeah.
that generates a new list. But why does it have to be only for lists, right, or sequences? And so he came up with transducers, which had this whole thing that was like this layer underneath map, filter, reduce, all these things that now can become transducers that allows it to separate the vehicle, so the data structure or the core async channel, from the operation, right? So now,
is it true that the within core async there were methods being added to that namespace, like a special form of map that worked
right,
with them and filter and all those kind of things. And after a
exactly.
while,
You just
Rich was,
re-implement everything, yeah.
yeah, Rich is like, this doesn't feel right. Let's back up
Right,
and rethink this. And
right, right. And so, yep, that's what transducers is. And then, of course, you kind of have to learn this like really abstract thing that's going on behind the scenes because he wanted it to be general and reusable. So you need to be able to do filter, you need to be able to skip elements. To do map, you need to be able to transform them. To do reduce, you need to be able to end early. So there's all these things that are like complications of it that feed into like what and how it actually has to work. And to make your own custom transducer, you have to define 3 separate functions.
yeah, and
They're different.
it did start to go to the monad world, kind of, right? It was like at that periphery of people's ability to understand and grok,
Right,
and yeah.
right, right.
I mean, especially
And,
if you dig deep into it, you're like, man, complex stuff.
yeah. And like when it first came out, I was a little concerned because there is something really nice about the way you can define maps over sequences. Like the sequence interface is just first and rest, right? And
Yes.
so there's only 2 things you can do with it. You can const onto the front, right? And so then what's cool is then you can define everything else in terms of those. So it is the sequence API is a layer below map and filter and reduce. And it's so simple. Like it's just it's simple in the sense that in a couple of lines you can write map, right? Filter in a couple of lines, right? Reduce in a couple of lines. There isn't that much to learn. But then when you get to transducers, it's like, this is not beginner material anymore.
Right.
So it concerns me as a teacher. Like it's kind of like it's somewhat of the opposite direction I think things should go in.
It didn't even Rich say something like it's one thing to like consume a transducer like a normal human, but then it's another thing altogether to write libraries that create them and like fundamentally making brand new transducers is
right.
like an expert topic then.
Yeah,
Because
exactly.
of all those things.
Well, and that's the problem with if you're saying you're using transducers to write cleaner code, if the code is not easy for the next person to reason about or work on, then is it actually cleaner?
It's a valid concern, but the API, if you're just going to compose existing transducers, meaning you're calling map with just the function or filter with just the function, just the predicate, it will create transducers that you can then compose up, and that makes a new transducer, which is pretty clean, right? And it's clean also in that now this transducer, can work on both sequences and core async channels, and presumably other kind of sequential data things. And so there's a talk by Tim Baldridge. It's about core async, and in the talk, he gives a lot of advice about like how do you design around. One thing that he was warning against was building a library that depended on core async So like you would give it a channel and it would put all these values on the channel, and it would transform your channel, the channel you gave it, into a new channel. He's like, that's what transducers are for. So you should make the interface of the library that it gives you a transducer, and now you don't have to depend on core async, right? The transducer contains the transformation.
Interesting thought. So like,
So that makes it more modular, right? That this transducer can now separate out what the concern of like the vehicle.
I was thinking if you were going to write a function and you were trying to be higher order and you were going to accept a function that underneath the hood maybe would map that function over something, you could say, hey, maybe I should take a transducer instead.
Yeah.
And just kind of open the door for more stuff.
Yeah, right. And there's this other thing that happens. I think I do it a lot, where you write a function that basically chains a map filter of map filter, and it's just like this big thread macro with maps and filters and stuff.
A pipeline kind of, yeah.
Right. And so it's like at the top you pass in a collection and it does this pipeline and it returns a new sequence. Like that could be a transducer that does not care what kind of data structure it's running on. Because all those functions have the transducer version. And then it could work in core async stuff too. Yes. And it could also be composed up as well, right?
So it feels like we as a community, if we could somehow level ourselves up to start using these things, we would gain by getting this extra flexibility. And I think I want to argue that we haven't. Like at large, people do not use transducers.
I agree
on their own like this. But that's not to say we shouldn't think about the idea,
Because that pipeline pattern is a really common pattern.
Yeah.
Yeah.
Because a lot of what we end up doing is just a sequence of data transforms. You put something in, you get something else out on the other side, and it goes through a lot of stuff.
And what the transducers allows you to do is write it almost exactly the same way. So instead of the thread macro, you just use a compose, and then all the maps and filters, all those forms are exactly the same.
But then, what do you really get out of it then? If it looks the same?
Yeah, that's a good question.
It's a good question. You get two things. One is you have three things. You're not building intermediate sequences.
So you have the performance gain.
Right, that's the performance
for free.
gain.
And that's not why you would do it, but that's good. You won't complain. Yeah.
Yep. If you're doing a long chain, it might be significant. That's a lot of garbage. It's composable. So if you have another one of these transducers that it eventually is going to get chained into as well, and you have two pipelines and you're chaining the two pipelines together, well, you could now just do a compose of the two transducers. And so you're not, you're gaining that too. Like this can now fit into this bigger world. And then you're getting the ability to work on these other, in other situations. So the core async situation, there's the situation of like, so, you can pass a transform to into,
Yes,
I find that kind of thing really is where it shines, where it's like, now you're actually going to use this transducer. Like, oh, there's all these cool places to plug them in.
Do you get rid of the thing aesthetically that I hate about these pipelines is if you have a thread first, then all of your functions where the first argument is actually the thing that you want look nice, and then if you want to put it in any other place in the function, you have to write the anonymous function there. Yeah, and you get rid of that, or do you still have that problem?
You're probably more constrained, right, with transducers?
You're more
What do you think
constrained,
here?
yeah.
I mean, it's like you got to really fit into the pattern.
It would only be for these pipelines of like sequence function. Because often I'll use a
Yeah, that's a good way
pipeline
to put
that's
it.
like, do this and then get the first one, and
Right? Yeah.
then get this key out of it, and
Yeah.
then
Yeah.
and then I go back because the inside that key there was another sequence, and then I go back into
Like
using
there's a filter in there somewhere.
right, and so you'd have to chop that up and be like, well, this is a section of sequence pipelines that I can turn into a transducer step. But you do gain that ability to use it in all these little places you wouldn't have before. I don't have the habit. So I have, in
Yeah.
my newsletter I have a challenge every week, a closure challenge that's just like a little problem. And there's a couple of people who routinely send me transducers solutions to it. Usually they're done with like sequence pipelining. And with the transducers, sometimes I'm like, oh man, this is way, way over my head. Like, because they're like, oh, they'll explain it. I couldn't figure out how to do it with standard transducers, so I wrote my own, and I'm like, oh my goodness,
Okay, yeah.
this is tough. And there's like stateful transducers, and it can get serious.
One thing that's kind of interesting is like transducers aren't that heavy of a lift in terms of learning a new thing, and we all did that to get to closure. We were all open-minded enough to take on this weird-ass language,
Maybe.
and then we kind of
Yeah.
like now we're like the grumpy old people who won't learn something new. We're stuck here, God, sticking to my sequence abstraction, or maybe we have good reasons for not wanting to jump to this new level. Maybe the payoff is not great enough.
Now, do you get the same performance benefits with stateful transducers as you do with stateless ones?
I think there's potential for more benefits. So because you're cheating by having mutable state, you're not you can do things like I don't know. I'm the one I'm thinking of is someone actually had a solution to one of the REPL problems we did on the show, and we had to do something like skip every other element of the sequence, something like that, or like multiply every other element of the sequence by 2, and they did it with a stateful transducer that just had a Boolean of like whether I'm on the one that needs to multiply or one that doesn't need to multiply. And it just flip-flopped between true and false in the mutable state. And, it worked. And we did something that was like, okay, convert it to the index and then see if the index is even. And so we built all this intermediate like data stuff just to know whether we were on the even or the odd one.
Interesting.
Like we paired the index in the vector using map indexed with we did a lot of work.
In this case, if you're accustomed to writing your own transducers and you can create a stateful one right away that does this thing for you, and you can get over that hump quickly, then you can come up with a simpler solution to this particular problem, as a stateful transducer ends up being easier to grok.
Yeah.
But it's being able to overcome that hump, and to me it feels like writing your own transducers is almost like in the world of macros. Like you don't do it often enough to like be comfortable doing it, and like whenever you do, you got to look up stuff and
right. And and in another, you're probably just better off using a map filter chain. Like it's like how often do you actually use recursion, manually recurse down a sequence, right? How often?
right.
If you really need something complicated, you just go to reduce, right?
Yeah.
That's true.
If you can't
So it
do it
sounds
with
like
reduce.
The solution is you just have to meditate under a waterfall on transducers for like a couple of years, and then when you emerge, you'll be able to write your own and your code will be
You,
beautiful.
I think that you would shed on it, and that's the thing is Mike mentioned we all had this hurdle to go over to learn Clojure, but now we don't want to learn a thing. But I think that when you just let's say like we did, we started before Transducers, you you get to work from all these prior examples. Whereas with Transducers, it's kind of like, oh, we haven't really figured out all the clarity issues and it is like yet another thing to explore. Like, oh, I'm trying to make this as clear as possible. Okay, now there's like this whole world you have to choose from that's potentially clearer. Yeah.
There's this like I don't know how you would describe it, but it's like not enough of the Clojure programming community is comfortable with them. So if you ever do use one, all of a sudden there's some people who are reading your code who won't know what that means right away. And they'll have to learn it. So it's like not enough critical mass, and the community uses them frequently enough to overcome something there. Where it's like, it's like all of a sudden you're speaking a different language. I'm like,
Right, and you're speaking a different language that at the end of the day is only giving you performance gains. Right?
It has to be more than that. Yeah.
There has to be more because we already like the sequence abstractions, So it's not like we were asking for someone to solve this problem, We had a pretty good thing going.
This reminds me of something else that I wanted to mention. It reminds me of the Java I/O library, Clojure Java I/O library. If you look at it, if you look at the copy function, it's not. If the doc string doesn't explain this, I think, and you have to actually look at the implementation. But I/O copy delegates to a method called doCopy, which is like a def multi, and the consequence of that is that you can kind of extend the copy functionality to anything else that you can like. It's like open for extension. You can define your own, because the def multi goes on like think the type of the target, where you're dumping it to, the type of the source. So like you can fashion your own thing that will like make the copy operation work over other things like database results or whatever. As long as you can grab onto it with a type and do your own def method for it. You can make I/O copy work with that kind of stuff.
I actually might need that. I'm going to make a note of that.
So you could, in theory, say, I'm going to come up with an idea that's like, copy this SQL statement to this stream.
Okay, yeah.
And it would recognize it as a SQL statement, query the database with it, and then copy.
Maybe a stream of I guess you have to deal with like bytes or whatever, of course, because that thing is at that low of a level. So if you had something,
there's stuff in the Java.io library to handle that, isn't
there? Clojure Java.io.
Yeah.
Well, there's something about converting files and URIs into streams, right?
Yeah, it covers most of the basic things you might expect. But if there's some other weird type where you can get a stream of data, a stream of bytes, or stream of characters from it.
So like let's say a HTTP request, like you could get the stream of the body. You could literally just get the stream, right?
Yeah.
But you could have it do that for you, and so you could say, well, copy this body to this. Let's copy this request to this response. So I'm just going to stream as the user uploads a file. I'm just going to stream it to some other thing.
Yeah, that's pretty open. If you ever run into anything like that, where you need to copy to or from an input stream to an output stream or whatever, I think it's based on that or readers. I can't remember, but it's
That's cool.
If you need to do that and you find something weird that's not supported by it, it is open for extension. This whole core async thing reminded me of that because it's like, or transducers reminded me of that. It's yet another way of getting extra flexibility to plug in your own underlying stream of stuff that you want to do things to.
Mm-hmm. I wonder if that the Java library, not the closure wrapper around it, but if the Java I/O package with the input streams and the output streams, if it isn't underused in that way, in the sense of like someone creating their own input stream wrappers that transform the input stream in some way. I don't know. Maybe it is used a lot, but there's the standard ones that I can think of. There's the buffered input stream, so it just adds a little buffer. So if you read 1 byte, it doesn't just read 1 byte from the stream. It tries to read fill the whole buffer up. But it could be something else. Like it could be converting from one encoding to another. Could convert from little endian to big endian. Could you could, in theory, just like with transducers, build up this giant chain, this pipeline of transformations that did that.
Yeah. One thing I did specifically do is inside of Plonk, at least back then, at the time, Plonk was only for Mac OS. So I made it so that Plonk basically has a ripoff of Clojure Java I/O inside of it, so it has like primitives that work on files and, so it lets you do I/O from Plonk basically. Right. Instead of me making up a brand new way, I just kind of ripped off that library as a way to do it, of course. But one thing I did do later on was like when you say you want to use I/O copy to copy from a file to a file, if both the source and destination are files, you can then on macOS do the
shell out to CP.
Well, no, it's actually even better. It's the new file system on macOS has that thing that's like a ZFS. You can do a copy where it's just like a pointer reference down in the file system.
Like a hard link or something?
Kind of, yeah. It's like a little, I can't remember the name they use for it. It's like a snapshot.
It's like virtual copy,
Yeah. So you can.
And so if you change one of them, then it finally does it's like copy on.
Yes, exactly. Yep. So that's like if you could even perhaps do that in Clojure if you could grab that thing and say, oh, okay, I know it's a file to a file and I know I'm on Mac OS. Let me do this highly efficient copy. That's an example where it's not even necessarily a stream of things. It's that the source happens to be a file and a target happens to be a file, which is kind of weird.
Well, yeah, and you're just working on different levels of representation.
Yeah.
I had a thing where I was doing a lot of copying of big files, right? Okay. And a lot of it is like this file is on the hard drive, but then in another time the file is like on S3 and I'm going to have to stream it. And another time is the file is on this HTTP API and I'm going to have to stream it from that. And so I wanted some way to unify this so that I wouldn't have to think so hard about like what the source is versus where it's going. And I could be able to just have like a little descriptor that's like, here's a file. It's actually in a zip file in this location. You need to get that out and stream it, and you need to store it on S3, and things like that. Just so that I could be more declarative about it, because the tales of like of doing it imperatively was getting annoying.
So maybe that's a good example you brought up is S3 itself. You could make a little library, a Clojure library that like will make S3 compatible with Clojure Java IO's copy. You just say, okay, I'm going to do a def method for that.
Right, because that was one of the things. Like, if I'm pulling from an HTTP API and I want to save it in S3, okay, I have to stream through my machine. Like, there's no other way to do it. But if I'm streaming from S3 back to S3, there's a copy operation that I could do
Yeah,
that would be way
see
more
that those
efficient.
both are targets and just do it directly.
Exactly,
Yeah.
exactly. And I thought that would be a cool little thing to write. I never got around to it. I just kept fudging with it until it worked. Yeah.
And that's what I find is interesting is just the fact that is so open for extension. You wouldn't even know it unless I think the only reason I knew was because I read Stu Halloway's initial book on Clojure, and he has a whole chapter that kind of goes into this aspect of that library and how it's like very flexible and.
Yeah, we were talking about this before, Mike, about how there's all this stuff that's I feel like locked up in these early books.
Yeah.
That because the people who were early to Clojure, I don't know if they just had less to learn because they were there at the beginning. There was less stuff, but they were. I see it in Joy of Clojure. I see it in Clojure programming. You're talking about programming Clojure, Stu Halloway's book.
Yeah.
There's all sorts of nuggets like that, like hooking into the REPL and hooking into I'm thinking about exception system. I think I remember something like that, or the printer, or all these things that I just don't do that day to day, and I'd have to relearn, or all the earmuff variables and what they all do. You know what I mean? I don't change those, but I think if you were among that early set, you remember when that earmuff variable was created.
Because it was novel back then, yeah.
Yeah, it was novel. It was announced on IRC, and it became a thing that you did, and then you wrote about it in your book. And I really want to mine those things. One day, just sit down and figure out what's all in there.
I mean, some of these things clearly became conventions and clearly became things we do now. So the question is, why did some of the other things fall out of use? Is it just that you don't need them as much, or they entered into these core libraries that we use so we don't have to worry about writing our own?
Yep.
I wonder, how would you work into the docstring this property of this IO copy? Because Mike, you said it wasn't
to do copy.
But then I suppose you'd have to go and look at the docstring for do copy to know. How would you? I would want to. How would you tell people that this extensibility is there and all the things that you can do with it in a docstring?
Right.
Maybe the fact that do copy is open was not really something the authors of the library were comfortable with exposing at the time, so they just kind of left it in there, just speculating. But it is extremely flexible, Once you know that trick.
It's a similar situation to all of the interfaces, the Clojure interfaces, like iAssociative. Is that actually exposed as part of the public API of Clojure that you can?
Oh, okay.
That you can extend this and it should be there forever, I mean, I think a lot of people do assume that, but I don't know if it's written anywhere that says that this interface is part of the public API and this class is not. This could change at any time,
That's also a big difference with ClojureScript and the fact that ClojureScript is based on protocols instead.
Yeah.
It'd be nice if we could all somehow change Clojure to use protocols, but just to make it consistent.
Right.
Yeah. That whole problem. We have something that works, so don't mess with it, kind of thing.
Right. Yeah, and Rich has talked about how, if you're making low-level language things, he wants it in Java. Right?
Okay.
Yeah, when Zach Tellman was working on the small vectors, he was generating Java because he talked to Rich about, Rich said, well, it has to be in Java. Which is interesting, right? It would probably be a few lines of Clojure code. Instead, he had to write a few lines of Clojure code to generate hundreds of lines of Java. Yes.
Yes. And that's also a big difference with ClojureScript and the fact that ClojureScript is based on protocols instead. Maybe the fact that ClojureScript is open was not really something the authors of the library were comfortable with exposing at the time, so they just kind of left it in there.
And
Yeah, I
who
mean,
knows why? I mean, he probably has some idea that like the Java's easier to guarantee certain properties of.
but with one argument I'd make is with the way ClojureScript ended up being based on those protocols, it would be really nice if that were part of the formal language that we all thought of as the spec of the language, because
Hmm.
then you could do great things. You could say, "Oh, this is I counted," or whatever. You can do
Yeah.
things that are
Yeah.
like is up at that level of the Clojure level, rather than like,
Hmm.
"Oh crap, I got to deal with this Java interface and
Hmm.
I mean,
almost read the source code to
Yeah,
understand it."
for sure.
when the decision was made to, or when I guess when this paradigm was set to do these things in Java, did ClojureScript exist?
No, that was it was a bootstrapping problem, right? Like
Yeah.
Yeah.
Clojure didn't even exist yet, so Rich
It
was
was
creating Clojure for the first time. Yeah,
it was several years before protocols were written.
were created and written. Yeah. So when
And
ClojureScript was created, Rich was like, "I'm not gonna. Now that we have these facilities, I'm not gonna repeat the old way of doing it."
I think he mentioned that in that recent talk and paper that it's one of the things that he I don't think it was in the like things I would do differently section, but it was kind of like it would have been nice to do protocols first,
Okay.
but I didn't. So, we're stuck with these Java interfaces.
Yeah, and I guess to try to introduce protocols now would be a breaking change too.
Yeah, I mean, it's a breaking change in the sense that even if you could, re-implement everything in Clojure exactly the same, like there's probably some corner cases that you're not thinking, or like bug for bug,
Yeah.
reproducing bug for bug. Be tough. Well, we've talked about this a while. I think it's a pretty interesting discussion. We still got it, even though we're not doing it so regular anymore. There's another topic in our show notes. The topic is a release of a library called Regal. Regal is a library. It's basically Hiccup for regular expressions. So a vector and keyword based way of representing regular expressions. This has been done before, but the cool thing about this one is that it can go in both directions, from regular expression to Regal and back, and it works on all the platforms. So it works in JavaScript, Java 8, Java 9. Presumably, if the regexes change again, then it'll work on the new platform.
So you can give it a
And
regular Java regular expression, and it'll turn it into this hiccup syntax.
right, there's a
That's pretty
function
impressive. Yeah.
for doing that, and so it gives you a way, first of all, to write the same code for in your CLJC file for the JavaScript and the Java, because you can
Whoa,
write it in
okay.
Hiccup,
Yeah. Nice.
and it's very. I guess it detects where you are, like
sure,
before it converts it,
Uh-huh.
and it's much more readable. So
Is it a
instead of
macro-based thing, so you're not giving up performance or whatever?
it looks like it's done it wrong.
Okay, all right.
But you might be able to do it in a macro if you.
So you
That's
can
cool. Just curious. That's fine. Yeah.
you can also override. So it says by default it takes the flavor that is best suited for the platform, but you can override it with flavor. So if you want to specify that it is an ECMA or a Java 8, you can override that.
So you're running on the
default there and do that.
JVM, but you want to generate a JavaScript regular
You can
expression.
tell it to do that, yeah.
That's cool. So it gives like this bridge. So if you need to convert between JavaScript and Java 8 regular expressions, it can do it. You just go through Regal. And then at the same time, it's got this other thing that it takes the Regal expression and it can convert it into a test check generator. So you can generate strings that match that regex. So I don't know if that goes the other way, probably not. But that means you can take an arbitrary JavaScript regular expression, go through Regal, and then convert it to a test check generator and generate random versions of or random strings that match that regular expression. Pretty cool, I think.
Yes, because I mean, regular expressions is like a little sub-language inside these languages that we've learned.
Yep.
And I guess if you learn Regal, that's another language, but it's like, feels a little higher level. Feels like it's more data oriented, right?
It's
It
not
looks like
read
it
once.
Okay, that's a good way to put it. It's not Perl.
It's not line noise. Yeah.
Perl
I
is a
think
big regular expression. Yeah, it's built into the name.
I've written code that was supposed to be cross-platform, meaning Java and JavaScript. And I've had this problem where I like write it in Java with a regular expression in it, and I think it's cool, and I try to run it in JavaScript and it breaks, and I have to debug it and figure out why. Oh, they use this \T instead of. It's like, oh goodness! And then now I need to have a little switch statement in there, one of those compile. What are they called? Those expressions. Yeah, conditional expression.
Yeah.
Reader conditional. That's right. And this would avoid that. I could write it the same way for all of it. That's nice.
This is Clojure and ClojureScript's killer app. This is how we'll take over the world. Because it's not just us who feels with this.
So
it's like,
much time.
like everyone, there's like so many people who are like, why the hell are JavaScript expressions different than Java's? Everyone suffers from these differences. Like why?
Well, and when you're writing something where it's based in Java and JavaScript, like it's a real pain in the butt.
Just turns you off of the whole idea of regular expressions, and you want to avoid them. But they're so cool. You keep coming back to them. You need them.
Yeah,
very
right. Like
declarable.
avoiding regular expressions is like
not an option.
That's a thing we do. Right? What's the it's like one of the oldest jokes, right? You have a problem, use regular expression. Now you have two problems. Like,
except it's 4 problems because it multiplies times the number of platforms.
Yes.
How many different flavors of regex are there?
As many as there are Unix systems out there. No, I don't know. There's the Perl ones. There's the grep compatible ones. There's the JavaScript, and they're like mostly the same. It's just
it's like Markdown, but just
yeah. It's just when you start getting into interesting stuff, like I need to match like non-punctuation marks. Like, well, how do you do that? And how do I make it case insensitive? And there's like those kinds of things are not standard.
The Regal. Check this out.
They are.
Yeah, I'll use it.
I wonder if the data representation is a little bit more readable.
Yeah.
It is? Okay.
Oh yeah. To be able to say : white space.
Yeah, okay.
Yeah.
Instead of colon line noise.
Yeah, exactly. And it's like there's a cool thing, and I've linked to it in the show notes. It's called Land of Regal. And there's like a couple boxes. It's like you can type in your Regal expression here, and it'll show you the regex, and it'll show you what it matches from the other string. So you can change that string too. And so but it's all bidirectional, so that means you can change the regex and see how it represents in Regal. You can change the Regal, see how it represents in regex. And I played with it. Oh, and then you can be like, and then what does it look like in JavaScript? What does it look like in Java 8? So you can click around, and there's stuff that like would have avoided bugs that I've seen, where like I didn't think that there were 17 whitespace characters, but you type : whitespace and it fleshes it all out. So
they have one for vertical whitespace. You just do : vertical whitespace, match only vertical whitespace, new lines and vertical tabs.
Are there cases where you have like a regular expression in, say, Java that cannot be represented in JavaScript?
That's a good question.
Like it's just like.
That's a really good question, but I think that the goal of this is to eliminate that. So even if there's no character class
Mm-hmm.
it will just like
Make
expand
it up.
into
Yeah, it'll make it. Okay.
exactly.
Ooh, they expose a spec definition of the grammar, so you can use spec
Oh, to check
to
that you're regal
yeah,
conformant. Oh,
yeah.
that's cool.
Oh, I love that.
See, this is the kind of thing that spec was made for, of like being able to, it's probably parsed with spec, right? Instead of some custom parser.
Oh, this is written by Arna,
Mhm.
Texas. Yeah.
Oh, I didn't mention that. Yeah, it's Arna from Lambda Island.
High quality stuff. Not that you should attribute a person to the library, but I will in this case. Yeah. You can trust it even more. I am that way. I trust a library if I know who wrote it. I'm a human. I trust other humans, as opposed to some random library out there.
Well, it is
Yeah.
it is nice not having to worry about rehabilitating someone's 5-year-old weirdware.
Yeah.
Wow. Yeah, this actually takes care of not ever becoming weirdware you have to rehabilitate by not declaring any dependencies. That's really interesting.
What do you mean by that? You don't declare.
It says Regal does not declare any dependencies. This lets people who only care about using Regal expressions to replace normal regexes without imposing extra dependencies on them. Because like the older, when you're trying to use a library that someone wrote 5 years ago and then they
Okay.
like stopped writing closure or died,
Mm-hmm.
all the dependencies are out of date. None of them work with your dependencies, and you spend a week just dealing with that.
Yeah,
Right. Yeah.
it's
So
true. It
not
uses some
declaring.
weird XML parser or something, and like, oh, that's not there in Java
Yeah.
9 anymore. And like,
Yeah,
So.
or like one of these
Mhm.
like kitchen sink dependencies that, fell out
mhm.
of favor, but
Like Apache Commons.
yeah,
Let's just,
yeah,
yeah.
yeah. Or it doesn't work with your Timber log. I like
That's
not
true,
declare.
actually. Yeah. I mean, if you're
Yeah,
going to take on a dependency, if that one is not taken on any others, that makes it so much more palatable. Yeah.
yeah. This is like that. That
Mhm.
actually that makes this timeless to me. Like that makes this almost like
Mhm.
it has a feeling of being core, even though it's
So
not
that
part of
means
core.
that means that it must have some conditional in there, like is spec already here,
So
right?
you have to require it. So if you
Right.
want to use the real generator, you will require closure test.check.
Uh-huh. Right.
If you want to use the spec generator, if you want to use spec alpha, you will need to require closure
But
spec alpha.
but what I mean is when you're compiling this library,
Gotcha. It should
you
search
have
for it. Yeah.
yeah, it's got to conditionally be like I'm not going to even look for it because it's not in the dependencies. Right? I mean, I would love to read an article about how to do that.
Yeah.
How
'Cause
to
I don't see
develop a
anything here.
library.
That like at runtime figures it out.
Yeah. 'Cause I don't see anything here that like throws an error if it doesn't, or like I guess, well, obviously the error that would be thrown is you don't have this, so maybe that's enough. I don't see anything that checks and sees if it has it first.
Right. Because I know that in Clojure Core they had to figure this out too for spec, right? And then spec does it for test check. It has some way of using it if it's there, but then not depending on it if, itself.
Yeah. Is it the requiring resolve thing or something along those lines? It's a
Yeah.
dynamic thing.
Right. And it's a cool idea, and I
Mhm.
wonder if there's a potential for someone to like explain how to do this. Because when you're what I mean is like if you wanna develop on Regal, you wanna say I wanna contribute to Regal.
Okay.
So you load it up. It doesn't have any dependencies. Now you want to try out the test check stuff. Well, you didn't load it up. You did not add that dependency to your class path. So how do you test that out? How do you develop on that? So is there like a separate depths Eden that's got a, or I don't know. It seems like a cool challenge, cool problem.
I think that's the first time I heard of a library that has no dependencies. That's cool.
Yeah.
Not even on the language itself. Like, I refuse to have any dependencies. Yeah.
Oh, I see. So they have aliases that
Okay.
that will add the dependencies. It has an extra depth. So the aliases are there's one.
Oh, there it is.
You can do spec alpha, and it'll include spec alpha as part of the dependencies. And these are all under the dev aliases. There's spec alpha 2. There's instaparse, which was weird. I wonder why you would need that. Test check, test chuck. You could just add in all these aliases to get them, so you can customize the way your dev environment is set up. That's cool.
This is a relatively new library.
Mm-hmm.
I like it.
Yeah, very cool.
Thank you for bringing this up, Eric. I'm going to go check it out.
Yeah, and the docs are really good. They're short, but I feel empowered to use this from reading the docs, which is nice.
Yeah.
Mm-hmm. Yep. Yeah, Arna's really good. He knows what he's doing. He also has Kaocha, the testing library.
So it looks like, that's what he's using for the test
For his
alias.
test.
I love these aliases for deps.eden. They really it's so nice to be able to separate out the stuff that you only need for testing or that you only need for working in the REPL and the stuff that you need in production. It makes maintaining the dependencies so much cleaner.
Mm-hmm.
Yeah, it makes it also easy to set up like little commands that you want to do to run stuff.
Yeah.
Just make an alias for it and put in the good
We're
stuff.
back
right
to
in
make files, huh?
there. Yeah.
The way it should be.
It's an old idea and it's a good one. Yeah.
I'm so old school. I love it. Works. It just works.
Everything was invented in the 60s or 50s. Everything. Nothing new.
Let's see, when did they invent Lisp?
58, right?
58.
But it wasn't
There we go.
implemented
Yeah,
until the
see?
60s. But yeah.
See, we've been done since then.
It's just been details.
Yeah. Oh yeah, 1958.
Oh. Yeah, I still remember before I worked at a company, and not that long ago, less than 10 years ago, we were still concatenating JavaScript files. There was no bundler or gulp or webpack, all these things.
It
And
sounds
it worked.
like a scary story you tell your kids, though.
No, but it
your-
worked.
No, but your tone of voice here, like your tone of voice is
When I was your age,
very
we were-
uphill both ways in the snow.
What do you? Oh yeah.
we
You're not that old.
concatenated.
Do you remember when there was no JavaScript?
Ooh.
When there was no Java? There was just C and C++.
And Lisp.
The dark ages. Yeah.
Those are
There's
the
always
days.
someone who can win that contest of like, I remember back, punch cards.
Found the bug on paper.
Yeah. I do. I remember when I was a kid, black and white TVs. Things I can barely remember now, but they existed. Yeah.
Black and white. I remember. Funny ears.
Yeah. You'd have to like
A lot of
move your
banging.
TV around to try to, bang it to get or have your brother or sister go and hold it so you can watch the TV show you want to watch. Mia's like, what the hell are you talking about?
Which
No,
to
I'm thinking
UHF?
about like how would you explain that to a kid?
Oh, yeah. Antennas on your TV? What's that? Yeah.
And we had one because my father would never pay for cable.
Oh, yeah. Yes. My kid asked me, like, what is that big satellite dish kind of thing, out there in that field? I'm like, that's the way my father was too cheap to pay for cable. So we had one
So
of
he
those satellite
stole the
dishes. You pulled out.
satellite.
Well, no, it was like you would get the free satellite signals until they started
Right.
scrambling some of them,
Right.
popular
Right.
in the like 80s. Those things were everywhere.
I had friends with
Cheap
those
fathers
things.
everywhere.
Yeah.
Yeah.
And you'd get the live raw feed from other
Yeah, exactly.
like news
the commercial-
broadcasts and
Yeah.
stuff.
They would
Yeah.
like flip to, you'd see like colors and stuff, and that's where the commercial would go, and then it'd come back to the regular show again.
And there's a high wind and nothing works.
Yes. Yeah.
We're
Okay.
gonna get lunch.
Enough reminiscing.
Yeah.
Folks, this was a pleasure. We're trying to do it more regular, but I think everything's just tossed up in the air and crazy. People listening, watching everywhere, wherever you are, I hope you're safe at home and you wear a mask when you go out. If you like the show, please subscribe and you'll be notified when there's a new one posted. Like I said, we're not doing them live anymore. There's too many technical challenges. Google threw away the easy option, which had literally just like one button and it would start streaming to YouTube. We tried various other options and they didn't work. So we're now just uploading a file like cave people.
Yeah.
None of us know.
I think we're
how
gonna
to
like
set
try
up.
a black and white version of the podcast.
It might work better. Bang it on the side. Get those.
That's right.
Yeah.
We should like start broadcasting it. We're gonna set up our own television station. You have to move to New Orleans to receive it.
The little gun is out of sync. You gotta whack it back into.
Become a public TV show.
Ah.
I feel like eventually we should like consider something like Twitch or like some kind of streaming thing, but it seems like such a pain in the butt to set those up.
Yes.
Yeah.
No one really. I mean, it doesn't seem like any software out there makes our particular thing easy.
We're too weird and too esoteric,
I mean, it's just like a talking heads show about that wants to stream live and handle
Well, so
comments.
Twitch has like there are people that do that on Twitch.
Yeah. And what are they
but
streaming to Twitch? Is it like
themselves.
no? But I mean, yeah, I know it's themselves. But is it a Zoom window? Are they Are they?
Well, so that's the thing. Yeah, I have no idea, and I'm not a teenager, and I don't have one, so I don't know.
You
anyone who
can't
can answer
consult
this
with your
question
teenager.
for me. Yeah.
My technical assistant here, who's this tall, will set it up for me. Yeah.
If anyone, I guess, like if anyone has any suggestions, the Twitter account is still suspended, so we can't tweet from it, but we can check notifications, and we do get mentions. So if you tweet at us, we can read them.
Oh.
It's just suspended because Ray has to log back in, I think.
We can't even
Oh,
get
'cause
on
he has the
Twitter.
phone
It's so
number.
hard to do. Technology's failing us left and right.
I know.
I mean, like, yeah, hell is other people's apps.
So sorry, folks.
Yeah.
We tried a thing where I had two computers. One was connected to Zoom,
Yeah.
and then the other was streaming it, and that looked like crap. So
Maybe if like after COVID's done, we'll just have to do a traveling show because that won't fail. We'll just go and talk to people directly.
right. If
Man
reality
on the street
starts,
interviews.
Yeah,
about
if reality
Twitter.
starts to fail.
like the artifacts, like what is going on with this? There's some weird compression artifacts here on this live people. Could happen.
Hopefully, next time we stream, I'll have a newborn.
That won't disrupt anything.
No, but but it's like it's a potato that makes noise. I don't know. Like, it should be fine, right?
We'll see.
Just don't put it in the oven. All right, folks. Thank you for watching. We'll see you later.
Later
Well,
on.
you'll see
Next time,
us.
everyone.
We can't see you. All right. Bye-bye.
See you.